I think we had Open Compute, and then I had Nanog with a couple of members, and then we had our first Wednesday of the month. We take that one off just because there's a couple of conflicts there, and it's number one, it's nice to have a break, and number two, a couple of companies take that first Wednesday off. So I guess we are back together again here. I'm going to go ahead and share my screen. So I had a couple of things today. I do want to start off that Farhan from DreamBig Semi is going to give us a presentation. But just real quick before we go there, I don't know if you can see this Power BI I've created. If you guys can see. Don, can you see?
I can.
Yeah, okay, cool. So I'm just, doing a week over week trending of PRs, and it's kind of interesting all the work we get done. And this one specifically, like I can tell within the last 21 days, I'm pulling from the public GitHub APIs and looping through those so I can make sure and get them all. But I've done a stare and compare with the actual GitHub UI to make sure I'm getting the right ones, just because I'm filtering on certain keywords. So, for example, in the last 21 days, this is quite a lot. This is a lot to have merged, 16 in the last 21 days, and then the different, repos that we're working in. And I might start sending something like this instead of the other view that I send in our comms. And then these are merged, and then this is how many is created in the last 21 days, which is 33. So and then of course I follow up on these and during the week and try and keep updated. So just FYI, a lot of work there. And I'll probably start sending a snapshot like this unless you guys like the other view. I also have today, we had Farhan here to talk about the P4 based model for SONiC Dash to Python. And these, I don't know if you guys got these emails, but I did send it to SONiC Dash at Linux, list.linuxfoundation.dev. This is kind of why I wanted the comms to get to you guys, but these are the features we're going to talk about here. And so Farhan, did you want me to hand it over to you?
Yes, we can start.
Okay.
Okay, let me share my screen.
Hi, Ramesh. Thanks, I can see.
Is my screen visible?
Yeah.
Okay, thank you. So it's me, Farhat, and after that, Farhan will continue the presentation with the demo as well. So good day, everyone. We are pleased to introduce a Python-based model for the SONiC Dash project. This model enhances flexibility, simplifies integration, and supports a rapid prototyping of the new features into SONiC Dash. The list of contributors, it's me, Farhat, is responsible for overall project direction, coordination, and strategic planning within the DreamBig Semiconductor. Farhan Tariq led the technical design and implementation of the Python-based data plane model. Next is Mohamed Faqiunus contributed to the module development, testing, and integration. And lastly, we have Saad Mazhar. He provided the early stage design input and initiated the development phase during his time with DreamBig Semiconductor, but he's no more working with DreamBig Semiconductor, so he's not actively looking into this. The agenda for today discussion is we will discuss the motivation behind the implementation of Python model. We will see an overview of Dash architecture with both P4 and Python models, a comparison between the Python model and P4 model, and we'll walk you through the code base and directory structure. Details on the modification made to the CI/CD pipeline for this model. And lastly, we will see the demo with the Python model using the PTF tests. The primary motivation for introducing Python model was to address the limitations of the P4 language and to enable easier prototyping in Python. As P4 is not executable, that's why it's hard to debug if there is something wrong. Some restricted feature set in P4 compared to traditional programming languages. And also there is a constraint on implementing stateful flow in flow operations. But on the other hand, the Python model offers numerous advantages, like Python is commonly used for quick prototyping, simulation models. It does not require compilation, simple and straightforward debugging, has a rich ecosystem of tools and libraries, and it also allows easy integration with APIs, internal and external systems. This is a high-level architecture of the Dash project. In the whole diagram, this section represents the Dash pipeline implemented in the P4 language, while the remaining components depict the testing infrastructure built within the CI/CD pipeline. After compiling this P4 model, it generates three main files. The dash pipeline.json file is utilized by the BMV2 simulator, while the other two files are used to produce the SI headers through this Docker container image. This PTF framework is employed to create various test cases. This BMV2 model receives control messages from the SI thrift server.
Hey, Farhat, real quick question. I still see contributors slide, and it looks like you're talking about something else. Are the slides not advancing, or am I looking at the wrong thing?
I see architecture.
I see
overview.
architecture as well.
Oh, okay. Could just be me. Sorry about that.
You want to maybe drop and rejoin, or keep going, Farhan?
We can continue.
Yeah.
Okay, thank you.
Mm-hmm.
Yeah, this BMV2 model receives control messages from the site thrift server using gRPC, and the data packets is received from the PTF or via with pair. So this is the old diagram we have taken from the older presentations.
That's Chris Summers put this together, I think. Chris and
yes.
Murcia. Mm-hmm.
And it's with P4. Sorry for not mentioning the contributor's name.
No problem.
This is the model, the architecture with Python model. So the testing infrastructure remains unchanged. However, the P4 and BMV2 simulator are replaced by the Python-based model. This Python model connects directly to the SI thrift server via gRPC and to the PTF framework through the with pair interface. For the SI headers, we have added few scripts that generates the same artifacts from the Python model as those produced by the P4 model. These files are then supplied to this container, Docker container, to generate the SI headers. In the diagram, this red dotted line illustrates the integration of Python model. So everything remains the same, like PTF, the SI, libSI, thrift server, everything, but only it has replaced the P4 and the BMV2 model. Some comparisons, very high level. Both model implements the same dash pipeline. Both share identical table structures and lookup logic. Maintains consistent routing actions and packet transformations. Supports similar P4 info and SI API generation, like for P4 we have. It utilizes the same testing frameworks, that is PTF and PyTests. So both the models, P4 and Python models, are working with the same PTF tests. Some differences, key differences we have is BMV2 uses P4 and C++, where the new model is implemented in pure Python. P4 requires compilation while Python doesn't need it. P4 is hardware-oriented language, whereas Python is developer-friendly and well-suited for quick wrapping. Debugging is simpler in Python, and the BMV2 simulator is multi-threaded, but for now, the Python model is single-threaded. From here, I would like to continue. Farhan, Tariq, you can share your screen and continue from here.
Can you take a question at this point or not?
If it's relevant to these slides, yes, but it's better to we have some section for questions. Maybe
We'll hold it. Yeah.
Okay. It's still very high level, so let's wait for the presentation. But I can continue.
Thank you, Farhat. I will take it from here and talk about the directory structure of the Python model and how it relates to the BMB2. Okay, so both the BMB2 and the Py model are located in the same directory called the dash pipeline. And inside the dash pipeline subdirectory, inside the Py model subdirectory, we have a few important folders. One of them is the control plane. This handles all the communication and the configuration logic. Then we have the data plane. This is where the complete main dash pipeline implementation lies. And then we have the libs subdirectory, which contains the supporting libraries or the helper modules, and the script subdirectory, which holds the scripts used to generate the runtime files. If you look at the control plane folder, this is where the files related to the communication and the control logic are stored. It includes files that handle gRPC communication between the Scythrift client and the Scythrift server. And it also contains the logic that processes the incoming gRPC requests, like adding or removing the table entries. There's also a folder here that stores the generated runtime JSON, TXT, and other files, which are used for generation of Sci headers, Sci APIs, and the Scythrift server integration. And then we have the scripts directory, which contains the generators that actually create these runtime files, and these files are similar to how the P4 compiler produces its runtime files from the P4 code. Okay, so now we have the data plane folder. This is where the main dash pipeline implementation will have. The file names and the folder structures are basically the same as are in the BMB2, so it's really familiar if you have worked with that before. Inside this folder, we have got a few key parts like the pipeline stages, which handle the different steps the packets go through, and the routing action, which defines how the packets get forwarded. By keeping the same structure as BMB2, it's super easy to move to the Python model without getting confused or having to make much or big changes. Okay, so this is how we wrote the Python dash pipeline code by referring to the original P4 code. On the left side, you can see the P4 code showing a pre-pipeline stage block, and on the right side, the Python model represents the same pre-pipeline stage using a class instead of a control block. The mapping between the P4 code and the Python code is quite straightforward. A Python class mirrors the P4 control block, and unlike P4, here we didn't pass any header or metadata as arguments to the methods of the class. Instead, we defined them as global objects to make the implementation more simpler and easier to work with. A Python method or a function mirrors the action which is defined in the P4 code. So it's similar to the P4 code, and a custom table object mirrors the table object which is defined in the P4 code. Also, we have also kept the side table and the side values annotations to maintain the same semantics and behavior as in the original P4 code. All right, so next we will look at the difference between the BMB2 CI workflow and the Python model CI workflow. On the left side, we have the BMB2 CI file, and on the right is the PyModel CI file, workflow file. Both of these workflows are pretty much the same in structure, but the main difference is in what triggers them. The BMB2 only runs when BMB2 related changes are pushed. It completely ignores any updates to the Python model files as shown in this red box. On the other hand, the PyModel CI will only run when PyModel related files are modified and are pushed to the repo, and it will ignore the BMB2 changes. This setup helps keep things efficient, meaning each workflow only runs when it's actually needed, saving time and resources while keeping testing more focused. All right, so to work on the Python model, developers need to follow these steps. Developer have to update and modify the code to add new features or any other implementation. Then have to generate the runtime files for the SCI headers, APIs, and the SCI thread server. And then after that, we have to test the Pi model. For that, we have to, for that, the developer has to run the Pi model, and after that has to run the SCI server and the DP app data plane application. And after everything is running, the developer has to run the tests, which are the PTF tests and the Pi tests. This sequence ensures that any changes to the Python model are correctly integrated and tested before deployment. Okay, so what's the current status of the Python model? If we talk about the completed work, we have implemented the dash pipeline, including the routing, VNet, and ANIs. We have also developed packet parser for deparser, implemented table lookups and actions. And we have also integrated the data plane application, the DP app, and also set up the site thrift communication. On top of that, we generated the necessary P4 info and SCI artifacts and ran PTF and Pi test suits to verify everything is working correctly. For the future work, we plan to conduct the SCI Challenger testing framework with our Python model. And after that, we plan to integrate the fast path within the Python model itself. And for better performance, and we have to implement multi-threading within the Python model. Okay, so now I'm going to show the complete working of the Python model. For this, we need 4 terminal sessions. One of the terminal will be used to build the artifacts, and after that run the Python model. The second terminal will be used to run the DP app, and the third one will run the site thrift server, and in the fourth and the last terminal, we will run the tests using site thrift client. Okay, so I'll switch to the terminal and will show the working of the Python model. Okay, is my terminal visible?
Yep.
Yes.
All right, all right. So this terminal will be used to run the Python model. This one will be used to run the DP app application, and this one will be used to run the Scythrip server. And finally, this one will be used to run the PTF tests. Okay, so I'll start by running the Python model. So the model has been started, and now I will run the DP app. And I will run the Scythrip server with it. And now as everything is running, I will run the PTF tests. Okay, so the testing has been started, and it will take around 2 to 3 minutes to complete all of these tests. And after that, it will show the status of the PTF test, and it will show if any of the test is failed or every test has passed successfully. So it will generally take 2 to 3 minutes.
Very cool.
While we are waiting, I can just add one thing. Currently, the Python model is exactly equivalent to the P4 model from functional point of view. So nothing has been changed from the feature or functionality point of view. So we are targeting to just make it equivalent to the P4, what we have currently there. Whether they are good solution, they are hacky solutions. But in the future, we are trying to add more features within the Python model, which are missing or improve some features for which we have not very good solution in the P4. Yes, continue.
Yeah, okay. So as we all can see that all the test has passed successfully, and this is the final status of the PTF test.
Wow.
We can also run the Py tests as well. Yeah, we can see that 4 tests, 1 and 3 are passed and 1 is skipped. So the PTF and Py tests both are working, they are working with the BMB2 model. So yeah, that's it from my side. And thank you all for listening to our presentation. And if any one of you have any question, please feel free to ask.
Hey, this is really good, nice, and especially debugging with Python is a lot easier, and all those benefits are there. But in your slide for the comparison, like in that, you didn't show any performance-related comparison. So, kind of, where are we with respect to performance and scale? Can we do something related to? Are you in the?
Yeah, good question. No, currently we are targeting mainly to functionally achieve the same functionality as we have in the before. So that's why we have written that the current Python model is single-threaded. But yeah, we can work on the performance and look into how we can achieve the better performance. But obviously, the BMV2 simulator is in C++, so everyone is familiar with the performance of Python versus C++. That might be a little bit limitation, but we haven't explored that way.
Is it available for use for everyone, or is it like is it open source now?
Yeah, the PR is
yeah, it is open source. Yeah, we have shared the link. I will share the link of the PR in the chat here, and everyone can try and run the model.
I see.
We have also provided the documentation and the steps of how to run the Python model. So everyone can test and play with it.
That's
Have you?
awesome.
Yeah.
Go ahead,
So
Ron.
do you have a common place where we can make use of the resource, or do you each individual needs to use their own resources, and we specified the requirements there?
Yeah, the Python model is running within a container. So we just have to have the necessary Dockers and the Python model will be directly running into that container. So everyone can run it.
I see. Thanks.
Thank you very much. Any other questions for the DreamBig guys? Nope. Okay, I guess we can. Thank you very, very much. I appreciate that, guys. Please reach out to them and maybe you could put your email. Did you want to be reached out to via email or via PR on the repo, or what are you thinking?
Yes,
Farhan
I
and
have shared.
Farhan.
I will share my. Yeah, I will share my email as well as the link of the PR in the chat. So
Okay,
everyone, feel free to contact me. Yeah.
that would be great.
Yeah, we can communicate within the group chat as well of the teams. And also if something is important, like the reviews or feedback on the PR, so it would be better to add comments on the PR. But if someone needs other info other than the PR, so yes, you can reach out to us.
Awesome. So I was looking to move on to the weekly report, and my page is having trouble loading. Just give me 1 second here. So I'll go ahead and share my screen. Are you guys able to see my screen?
Yep.
Okay, great. So you guys are familiar with this view. And this view, I've been going over with different community members, just different statuses of stuff we're working on in the back burner. And we have our draft and our in progress items that some of them aren't the highest priority, some of them more are. And, I try to look through these once a week and twice a week and try and get reviewers, et cetera, and make sure they have the right labels. I am also working with the technical steering committee at SONiC to try and gain access. So maybe I can do some of this work. I pinged them the other day. But what we do have here is a few waiting for review. We have the source Mac rewrite. I know that Jing and Alberto and Murcia are working on HA. So we have, some HA test cases and UHD configs for the test cases, etc. And I know that we had this one was interesting. We had to disable a default route installed in the DPU. So this is awaiting review. More interestingly would be the done since our last session. And so it's been a few days, but it's, like I said, it's been quite a few. We probably can't go through every single one of these. It looks like this HLD for the container offloader, we decided to go a different direction. So we're going to go ahead and close that one. So that's not really work we've done. It's more we've just decided to go a different direction. We have the UHD custom config here. I don't know if Murcia and Alberto might want to talk about that in the future. And then we have a couple of fixes that have gone in for different tests, whether it's from Ramesh or Michael or NVIDIA team. And I think we had some fixes going in for 19700, which was the main SONiC management test. So a lot of these have been done, and I'm trying to pick out interesting ones. I think this one was interesting. Fix the flex counter bulk get here from the AMD team. That one was finished. And update the dash ENI counter test to align with latest PL test change. This one was also a good one. So this is what we've been working on. And in addition to these that are done, I need to go through these after I get off this call. I have a view here where I've picked the new ones, and I have to kind of check where we are in the different. These are created, basically, new ones that have been created. And so out of here, maybe this one might be interesting. Deprecate the traditional flex counter support. This is the one we just went over here by DreamBig Semi. And then we had a couple of here, an E&I based forwarding test and another fix here. So sorry if that was very high level, but that's what's going on. Is there anything you guys want to cover or talk about, or specific PRs? No? Okay, then I can give time back. Almost 30 minutes. And I appreciate the presentation, guys, and I hope you all have a great day.
Thanks, Christina.
Thanks, everyone, for coming. Oh, yeah?
Yeah, sorry, I have a small question.
Uh-huh.
So, in order to, I have a couple of small fixes or updates in the SCI repo, OCP's SCI repo. So I have opened the PR for one of them, and I didn't got any response yet. So, any path how to reach the OCP or the SCI guys for the update, or anything related to that?
You know I have an OCP meeting on my calendar. I think there was one yesterday. 8 a.m. on Tuesday, November 11th. That was yesterday. That was SONiC OCP project. Let me look around and see if there's a way to do that. And can you pop those PRs into the chat and I can add them to the project?
Yeah, sure. I will share it here in the chat.
Yeah, that'd be great. And then I'll take some time this afternoon and see if there's a way to work within their repo. Does anyone else know?
Okay.
Murali, have you worked in that repo much before, or?
No, I didn't pay attention to the question. I'm sorry.
That's okay. So there's a couple of PRs that are in the, did you say the SCI repo? SCI experimental?
Yeah, SCI, the sub-module which is used in the dash.
Yeah, and they're not moving forward and no one's really responding. And so I was wondering if anyone knew a contact there. Did you know anyone, Murali, or have you ever worked in the SCI repo?
I'm thinking maybe Prince or Riff or one of them should be able to help, I guess.
Yeah, and I can look it up. Yeah, I'll try, guys, and I'll send you an email and let you know what I find.
Yeah. Okay. Thank you.
All right. I'll do that. Thanks, everyone. Have a great rest of the day.
You do the same, Christina. Thanks.
All right.
Thank you.
Thanks a lot, guys.
Thank you.
Thanks for coming. Bye-bye.
Yeah.
Thank you very much. Have a great one.
You too. Bye-bye.
Yeah. Bye.